Hi, my name is Kushi, and this is my completed Milestone 4 for the Ethermart project. So some tasks I'll be covering in this video. I'll first walk through my MariaDB performance analysis, then I'll go through my robust ETL data pipeline solution, then I'll walk through the vector embeddings, as well as feature engineering and normalization, and then finally I'll go through my AI usage for this part of the project. MariaDB performance analysis is important to ensure that resources are optimized and that we aren't using more processing power that we need to, and also that our performance remains high when we're increasing the scale of the data that we're using. So it's important to analyze performance to ensure that we are reducing bottlenecks as much as possible. For example, if there's certain types of tables or certain queries that use more processing power than others, we can apply different methods to optimize those to not slow down the whole system. And some methods to increase performance in MariaDB include adding indexes to make reads faster. And if that doesn't work, then we could denormalize our data. We could also use materialized views. And if none of these methods increase performance, then we can also scale horizontally by adding more nodes to the cluster. So how to analyze performance? In MariaDB, I'm going to analyze performance by using the MariaDB monitor, which is automatically opened when I type sudo MariaDB. And I'll look into the CPU and RAM usage, check cluster health, and also show the amount of full table scans, which could be inhibiting performance. So now I'm going to go into my EC2 instance. And first, I'm going to check my CPU and RAM usage using a command that's called top. So I'm in MariaDB, and this is my primary node, and I am using my database, which is called e-commerce. So I'm going to type in a query, and I'm going to run this query. And this query is set to take 0.5 seconds for every row, and this is to make it last longer because typically when I query something, it's over instantly. So I can go into a different node and I can type the command top, and it's showing me how much CPU and memory is being used. So currently it says 0.0, but as you can see, it says 0.3, it says 15, and it changes. But basically you can see that it's much less than 100%, and this means that there's not that much CPU usage, so we don't need to upgrade our CPU or our RAM, which is shown by the percentage memory, in order to increase performance. So I'm going to stop this. The next thing I'm going to do is check the cluster health. So I'm going to type in the command show status light percentage. And as you can see, the first thing I'm going to look into is the cluster size, and it says that the cluster size is 3, which is good. It says that the cluster status is primary, which is good because this is the primary node, and this also indicates that there aren't any cluster partition issues. Um, the WS rep ready is on, and this shows that there aren't any replication or SST issues with the cluster. So if any new nodes are added, then the data should correctly replicate onto those new nodes as well. And yeah, so it seems like the cluster health is pretty good. The next thing I'm going to do is check how many table scans or full table scans are being used. So I'm going to type in the command explain, select star from orders, where customer ID, oh, equal to, and I'm just going to type in a random customer ID. And as you can see here, it says for type that it is all, which means that this is an all table scan, and that could not necessarily be good for performance. And you can also see under key that it says null, which means that the table is missing indexes. And currently this is not an issue because the amount of rows is only 200, which is not very much. However, if we were to scale this and if we were to add a lot more data into this table, then it can be a performance issue. And so the best way to resolve that issue is to add indexes to this table. So I'm going to create index. I'm just going to call it index customer. ID on, I'm going to add this to the orders table. And then I'm also going to create another index. And now I'm going to run this explain command again with this query and see what it shows. So as you can see, it now has the key index command ID, and it is only using the table orders, and the type is now ref. And this means that the indexes are working properly, um, and that we're not using the entire table when executing this query, and this should overall increase performance. So now I'm going to walk through my data pipeline solution for MariaDB. And a data pipeline basically provides a seamless process that moves raw data from its many data sources into the production environment. And the way I did this for Ethermart is by creating staging tables that holded the raw data for each of the production tables. And in a real world situation, data for one specific table can be coming in from multiple sources. And so using staging tables is ideal because we can pull in and integrate all of that data from different sources into one table and transform it before putting it into the production tables. So for Ethermart, I took the raw data, I loaded it into the staging tables in its messy raw format, and I created a staging table for each of my production tables. Then I performed all the transformations in the data before loading it into the production tables in a clean format. So now I'll go through how I did this in my EC2 instance. So I'm going to quickly exit out of MariaDB. Oh, and I'm going to open my full script that created all my tables. So I upgraded my schema script to create staging tables for each of my tables. So I created a review staging table, order item staging table, order staging table, etc. So here I created my production tables. And then here I created my staging tables, and I made all of the fields bar chart so that I'm able to keep the data in its messy format. Then I loaded the data into the staging tables, and then I applied the transformations and then loaded it into each of my production tables. So I'm going to exit out of here, and I'm going to open MariaDB. I'm going to use e-commerce, which is my database. And I'm going to quickly show the tables I have in here. So as you can see, I have my normal tables with my clean data. So categories, customers, order items, orders, products, and reviews. And then I also have all of my staging tables that have the messy data. So I'm going to quickly walk through go through some of my staging tables. So I'm going to select start from staging underscore products. And as you can see here, the data is a bit messy in its formatting. We don't currently have a product ID, things like that. So now I'm going to select star from products. And as you can see here, the data has been transformed and cleaned into this format. I'm going to do the same with a couple other tables. So select star from engaging underscore customers. And as you can see here, there's a couple of things that are still unclean. For example, the emails, the ones that are blank are not changed to null. There's no full name column, things like that. So now I'm going to select star from customers. And as you can see here now, the emails column has been cleaned and transformed. There's a full name column as well. As you can see here, it's kind of hard to see because it's a little bit big. So it's formatted like that. Then I'm going to look into my orders staging table. And here there's also a bit of messy data. As you can see, the dates are all in different formats, and it's important to convert all of these to the same format. And as you can see in the production table, all of the data is clean and all of the dates are in the right format. And then finally, for the reviews table, oh, some problems here that I cleaned up were that the ratings were all, some of them were blank, some of them were invalid. And so changing all of those to null and ensuring that they're between 1 and 5. So let's start from reviews. And as you can see, all of this data has been cleaned, specifically in the ratings column, where all of the records that were either blank or invalid have been changed to null. So now I'm going to walk through my process of creating vector embeddings. A vector embedding is a numerical representation of data in a multidimensional space, and it's really useful because it can convert objects like text, images, or audio into an array of numbers that can be compared to others for similarity. And this allows for semantic searches, which is basically being able to compare conceptually similar items without having to search for exact keyword matches, which might not be as accurate. And ANN, or approximate nearest neighbors, is an algorithm that finds the closest vectors to a given query vector. And since exact nearest neighbors algorithms could be really slow, especially in higher dimensional spaces, ANN can be more useful because it finds approximately the closest neighbors. And so it trades a little bit of accuracy for a much faster search. And in Ethermart, I can use vector embeddings to search for similar products or similar reviews. For example, I can create vector embeddings for the reviews text column and use those embeddings to search for reviews that are conceptually similar to one another. So now I'll go into my EC2 instance to show you how I created my vector embeddings. So I'm going to pull up the Python script that I created. And this is the Python script that I created to generate the embeddings for the reviews text column. And once I ran the script, it generated the embeddings in a JSON format. So as you can see here, I pulled up embedding from my reviews table, and there's an embedding created for each of the reviews. And these embeddings can be compared to see which reviews are more similar to other reviews. Now I will talk about feature engineering and normalization for the vectors that I created. So why should vectors be normalized? Vectors are normalized by being scaled so that all values lie on a specific range. Typically, it's from -1 to 1, or it could be from 0 to 1. And this means that the length or magnitude of the vector is converted so that its length is 1. And this is also called unit vector normalization. And when vectors are normalized, it's very useful because methods like using cosine similarity, which determines the distance between vectors, typically works better. And vector normalization also makes calculations faster and reduces numerical errors in distance calculations, like cosine similarity. And then finally, normalized vectors are typically more compatible with methods such as ANN algorithms, and they make them faster and more accurate than if the vectors were not normalized. And so why should we use more or less features in the embedding vectors? So features are basically the amount of dimensions that a vector has. So if there are more features, the vector typically represents the data in a more detailed way. And this can provide richer representation and more accurate comparison of the data. However, using fewer features is also important because it makes computations much faster. And so a sweet spot would be a number of features in the middle, for example, 768 features. However, this could be tested to find an even optimal number. And having a number of features that is sort of in the middle provides a balance between providing information that is more rich and accurate and overall query performance. So here's my AI usage for this milestone. I primarily use ChatGPT for this milestone since I'm the most familiar with it. And I use the AI to help me generate the SQL script to add in the staging tables and load in the data for the data pipeline. And it was very helpful for this task. The AI was also helpful in helping me download the necessary libraries I needed to download for generating the vector embeddings. However, the AI did also struggle. For example, it was not very helpful in helping me generate a script that created the vector embeddings. It gave me scripts that had a lot of errors. It also struggled with helping me solve an issue that came up where I ran out of storage space and was unable to download the libraries that I needed. So overall, the AI was somewhat helpful with simpler tasks. However, I still needed to understand what I was doing for it to really help me.